Hey, quick update. So on August 8th through the 11th, I'm going to be in Vancouver, Canada with the legendary Jason Van Gumster to go to the SIGGRAPH conference, which is the biggest conference in computer graphics where people from all over the world come to explore and share the latest advancements in graphics technology. We'll be there representing Orange Turbine, which is a new-ish company under the CG Cookie umbrella that has to do with consulting and custom add-on development. And you can find more about that at orangeturbine.com. But at the conference, we'll be handing out these thumb drives, which have Blender pre-installed. And also we'll be giving a live demo on that Wednesday, all about how to get started with geometry nodes for people coming from other software. Now, if you happen to be at SIGGRAPH, feel free to reach out, as I'd love to chat and grab coffee with as many people as possible. But for those of you who can't make it, that's why I made this pre-recorded version of the demo just for you. I'm also working on a full course on geometry nodes for cgcookie.com. That'll be coming this fall, so keep your eyes out for that as well. The first thing that I'll show in the demo are a bunch of cool examples of what people have done with geometry nodes, but looking at those examples, it's easy to think that you can do literally anything with geometry nodes. And I want to be clear, especially for people who are coming from another software and just getting into Blender for the first time, that the geometry node system is still reasonably early in its development. At the moment, it's already great for things like distributing assets, creating basic adjustable shapes, animating basic motion graphics, and creating pattern-based effects. It's extremely powerful for those things, but what it's not for is complex modeling. So don't think about them as modeling nodes, because many key modeling features just aren't there yet. Managing selection in any node-based system can be difficult, and computing extremely big graphs can be slow. So it's definitely not a modeling or animation replacement, but rather a great modeling and animation enhancement. Since it's implemented as a modifier that can be combined with any modifier stack, it's really easy to incorporate into your existing workflow as you learn the system. You don't have to dive in 100% all at once. So with that in mind, let's check out an example of how it works. For this demo, let's make a table that automatically adjusts to the size of a simple cube. Let's go ahead and start by switching over to our geometry nodes workspace in the top header. And then since we're going to base it off of our cube, let's make sure that that's selected, and then we can click New. This is going to add a new geometry nodes modifier over in the modifiers tab, which is where we'll be able to edit any inputs as soon as we add them. Now, we could start out by getting the top of our table by deleting these bottom points here and just keeping the top, but I'd really like to be able to round the corners here, but unfortunately we can't bevel any mesh parts in geometry nodes just yet. But we can do that for curves. So let's go ahead and just add a curve and then place it right at the top, and then we can go ahead and round those corners pretty easily. To do that, I'll create a new curve, Shift-A, Curve Primitives, and let's add a quadrilateral. I can preview this by holding Alt and then Shift and clicking on the quadrilateral. Over in Edit and Preferences, under Add-ons, just search for Node Wrangler and make sure that that's enabled. Once you do that, then you'll be able to switch between different nodes by holding Alt and Shift, and that'll connect it to the output geometry. So here we have our curve, but it's not really mapped to the size of our geometry. If we were to edit this by scaling it in object mode, just like so, then it will work, but only by stretching the entire thing. So for example, if I had a mesh primitive inside of here, and let's say we have a sphere, let's preview that instead. If I were to scale our object, it's going to stretch everything as a whole. And I don't want that because, of course, I want the legs of our table to be complete cylinders. And overall, I don't want anything actually stretched. So we're going to have to go ahead and transform this cube in edit mode instead. So let's preview our quad. And then to just get rid of the scale, I'll hit Alt and S, like so, to reset that. Tab into edit mode. And then I'll select each face by going to face select mode. Let's use our move tool, and I can just move some of these faces around. And this is what I want our quad to map to. So let's just make this a little bit wider, like so. And we want it to use the same width and the height, and also change its location so that it's at the top. Node with Shift-A, geometry and bounding box, plug the input geometry into that geometry. And if I hold Alt and Shift, then we can see the resulting bounding box, which in this case is the exact same thing as our cube. But even if we had, some other shape like a monkey, we're still getting a box shape. We'll always end up with a box. But what's interesting about this is that we can now get the dimensions of our object by using the minimum and maximum, which are X, Y, and Z locations. But in this case, the minimum is the -X, -Y, -Z location of our bounding box here. So that'd be this point. And then our maximum would be the positive X, positive Y, and positive Z, which would be this point. And we can get the size for any of our axes here just by subtracting one from the other. So let's get those sizes and then plug them into the width and the height of our quad. And subtracting the minimum. So let's take our maximum, type subtract, and choose vector math and subtract. We need to use a vector math rather than a regular math node because we need to do our operations on all three x, y, and z values at the same time. So let's take our maximum and then subtract our minimum. Now we need separate values for the width and the height, so we need to separate out our x, y, z. So I'll type in separate x, y, z, and then plug the x into the width and the y into the height. Now if I go into wireframe view and Alt-Shift in preview, now our quad is the exact right size. It's not in the right location yet, but that's okay. To jump it into the right spot, let's transform it. Shift-A, Geometry, and Transform. Then we can set the translation here. For the x and the y, we want it to be right in the middle of wherever our geometry is. That's also information that we can get from our bounding box. We just need to take our minimum and maximum and divide them by 2 to average them out, and that'll give us the exact center. So instead of using a subtract here, I'll hit Control-Shift-D to duplicate this down while still keeping those first connections. And I'll set this to add. Then switch these around just to make it a little bit easier to read. But then I need to take this and divide it by 2. So Shift-D, duplicate it, switch that to divide, plug the vector into the first vector, and divide each of these values for the x, y, and the z by 2. And separate it out. I'll take this separate x, y, z, Shift-D to duplicate it over, and connect it up. Now just so I don't forget what each of these do, I'll hit F2 to rename this separate x, y, z, and I'll call this average location. Then I'll select this top node, hit F2 to rename that one, and I'll call it size. So now we can plug this average location into our translation by combining the x, y, and z so that I can plug it into this purple socket. I can drag outwards here just to quickly add a node, and I'll use a combine x, y, z. I'll plug the x into the x, the y into the y, and the z into the z. So now no matter where I move this, it'll always be in the right spot, but the z will always be at the center when really we want it at the top. The easiest way to get that is just to use the maximum. So I'll Shift-D on our average location, F2, and I'll rename this to max location. Plug the maximum into the vector, and use that maximum z, because that'll always be the top. After that, let's go ahead and round these corners with a fillet curve node. So we can do that before the transform. I'll just do the transform at the very end here. We'll take the quadrilateral, and we're going to need a little bit more space, so I'll just move this up a bit. And let's go to Shift-A, Curve, and Fillet Curve. We can set the radius here, but if we switch this over to poly, we can get a few more points in between. I'll increase the count, let's say all the way to 16, so we can get a nice round result. Now if we go too far, it'll overlap, and we can set the limit radius. That way it'll just snap right at the end there. But I'd actually rather have this be based on a roundness parameter rather than a set radius. That'll be a little bit more user-friendly. So to set this radius based on a roundness parameter, let's go ahead and take our group input, and we could either just plug this all the way over here, drag it over, and plug this bottom socket, which is currently empty, into the radius. Then if we want to edit the input, we can hit N to open up our sidebar in our node editor, go down to group, and rename it or change any of the default values here. Now one thing that we can't change, unfortunately, is what type of input this is. So I actually want it to be a factor from 0 to 1, rather than a set distance. So I'll unplug this and actually just get rid of that radius. And instead, I'll just add something that I know has the correct type of input. And I really hope this is something that will be changed in the future to make it a little bit easier. But I'll go to, let's say, color and mix RGB. Then I can plug that nice slider into the input and just go ahead and get rid of that original node. So now I have this slider with a maximum of 1 and a minimum of 0, and I can rename this to roundness. Then I'll plug that right into the radius. So we can either set it to 0 or a unit of 1. Because if we just make this really, really big, now it's no longer reaching all the way to the other side. Now the roundness really has to be based on whatever the shortest side is, because if we had this to be, really, really short, then of course we can't round it based on the longest side, because then it'll start to overlap on this side. So let's just give it a radius of exactly half of the shortest side, and that'll be perfect. Luckily, we have our size information right here. We can just take the x and the y and find whichever one is the shortest based on a minimum operation. So I'll drag out from the x, type in minimum, and use a math minimum, and plug the y into the second value. So if we plug that into the radius, and uncheck limit radius, it'll be exactly double of what we need. So we need to cut that in half. I'll just Shift D and duplicate this node over, set that to divide, and divide it by 2. There we go. Now no matter how big this is, or what the dimensions are, now it's not really based on the roundness parameter anymore, so let's go ahead and blend between this size, whatever it happens to be, and 0. For that we can use a map range node, because we have a range of 0 to 1, and we want to change that, or transform it, into a range of 0 to whatever this dynamic value happens to be. So let's hit Shift A, go to Utilities, and Map Range. Our roundness is going to be the input value to drive the whole effect, and we know the minimum of our roundness is 0, the maximum is 1, so we don't need to change any of the from values. But we do want to change the maximum. We want the minimum radius to be 0, so that's perfect, but then we want the maximum radius to be this value. Then we can plug the result into the radius. Now as we change the roundness, we'll be able to easily adjust this effect regardless of the size of our object. Let's go ahead and fill it in. I'll move my nodes over a little bit, give us a little bit more space. And then after we've filleted our curve, let's go ahead and fill it in. Shift A, curve, and fill curve. And by the way, I ran a poll on Twitter of whether this is pronounced fillet or fillet, because I thought at least the engineering community would know, but even they disagreed, so I'll just pick one and stick with it. Anyway, now that we've filled this, if we go into solid view here, then we can see the result is just a nice flat plane with our roundness control. But we want to give this a little bit of thickness, and we could do that in a couple ways. One, now that this is a mesh, since the fill curve converts this from a curve to a mesh, we could extrude this downwards. But I'd really like to add a profile that makes this a little bit more interesting. So instead, I'm going to add a profile to the curve and then join this in with the flat top at the end. So let's use this curve and give it a profile. I'll drag it out and use a curve to mesh node. And both the fill curve and the curve to mesh node convert the curves to a mesh, so they could probably use to be combined into one node with different options, but for now they're separate nodes. And then we just need to plug something into the profile. But let's go ahead and join these two together so we can actually see them. Shift A, geometry, and join geometry. Plug them both in. And for the profile curve, I'll hit Shift A. First, let's choose a curved circle so we can see the effect. I'll turn down the radius. And that's going to give us a tube-like shape. But instead of that, I'd really like a line just going straight downwards that we can then take the vertices of, push them in and out, and make a bit more interesting shape. So instead of a curved circle, let's use a curved line. And that is what we want, but it's going in the wrong direction. So instead of having this go in the Z direction, let's have it go in the Y direction. If I set this to 10 centimeters, then it'll go straight down. But thinking about it, that's way too big for a table, so let's set this to something more realistic, like 3 centimeters. We can just type in 3 and cm. Alright, so now that this has the right thickness, how can we go ahead and change this profile to make it a bit more interesting so it's not just going straight down? Let's hit Shift A, geometry, and set position. The reason we're using a set position node instead of a transform node is because we need these diamond sockets. In a transform node, we only have these circle sockets, which mean they only input one value for all of the points all at the same time. whereas the diamond sockets can have different points depending on the different attributes of those points. So since we need to move some points more than others based on a parameter, we need these diamond sockets. And we want to offset it in the X direction, so that we can push the points out or in. But at the moment, we only have 2 points, so it's not going to be that interesting. We only have the start of our curve and the end of our curve. To fix that, let's subdivide this a bit. I'll give myself a little bit more space to work. Shift A, curve, and subdivide curve. Let's give this 12 points instead, and that should be plenty to work with. Then we want to be able to manipulate these points depending on how far along the curve they are. So maybe we want to move the bottom ones not at all and the top ones not at all, but push out only the middle. To do that, we need a parameter that goes from the start to the end. Let's hit Shift A, curve, and choose spline parameter. Then we can use that factor for exactly that. But I only want the x-axis, so let's drag out from the offset and type in combine XYZ. Then we can plug that factor directly into the x. That's going to be way too big because, of course, the first part of the factor at the start of the curve is going to be 0, but then the end is going to be 1, and 1 unit is way too big. So let's go ahead and divide this a bit. I think if we divide it by 10, that should be about right. So let's use a math node for that. Shift A, Utilities and Math. Go ahead and divide, and by 10. That's still a little bit big, so let's try 20. Okay, that's more manageable. To make sure that this influences only the middle points, let's use a float curve, which is kind of like an RGB curve, but only for one value. Let's hit Shift A, Utilities, and Float Curve. The x-axis of our float curve represents the input value, and the y-axis represents the output value, just like an RGB curve node. So to make sure that the bottom is in the same location as the top, let's take the end, that endpoint, and just drag it all the way down to 0. Then I can click and drag to make a point in the middle, and pull that up. And we can give this whatever profile we'd like. I'll just drag this up and to the left a little bit, and maybe left click and drag to create another point. Once you have a curve that you're happy with, I'll go into solid view, and you'll notice that we have a nice top, but it's missing the bottom. For that, we can just take our top. We can do that here right at the end, after this fill curve. So let's take it and just transform it down by 3 centimeters. I can use our set position node here. In this case, we're moving all of the points uniformly, so it doesn't really matter whether we're using the set position or the transform node. Either one works. But we just know we need to move it down on the z-axis by 3 centimeters. Now that we've moved that, we have a bottom but no top. So let's combine both of those results together. I'll move this up a little bit into the join geometry as well. So we have the before result combined with that after result, and now we have a top and a bottom. And that's that for this bottom one. The normals are pointing in the wrong direction, because for the top, the normals are of course pointing up, but we just shifted them downwards without flipping the normals. We can see this in our overlays with face orientation. The top looks blue like it should, but on the bottom it's facing the wrong direction. So let's go ahead and flip those over before we join it in with the rest of the mesh. Shift A. Since it's a mesh now, we can go to the mesh menu and go to flip faces. There, that fixed it. I'll go ahead and turn off face orientation. And lastly, the only other thing that I want to do for our tabletop here is get rid of those vertices that are overlapping each other. Because right now we generated a top, we generated a bottom, and we generated a side, but all of them have their points laying directly on top of each other right at this intersection. And we can kind of see this if we look really close. Maybe if we change to a different matte cap that's a little bit more obvious. Let's switch to maybe this first one, and it's kind of hard to see, but there is a sharp edge, and I'd rather that be a smooth edge. So to join everything together, let's use a merge by distance, so that everything that's laying directly on top of each other just gets merged. Shift A, geometry, and merge by distance, and that'll fix it. If I hit M to mute this and toggle this on and off, then you can see the change. You can also notice in our spreadsheet editor that with this on, we have about 952 vertices, but with this off, we have 1.1 thousand vertices. So we're getting rid of quite a few. But even though there's less vertices at the end, it's still kind of an expensive operation, so only do this if you need to. But with that, we've finished our tabletop, so let's organize this a little bit better. We're going to work on the legs next. So let's just take our nodes here. Make sure that they're nice and readable. Then I'll select all of them that make up that top. All of these nodes here. And then I'll hit Shift-P to create a new frame to go around all of them. And then I'll hit F2 to rename it to top. Then let's make the legs. Shift-A, curve primitives and curve line. I'll move this over on the side. Shift-A, geometry and join geometry. And let's join this in before it gets transformed, such that the legs move up and snap into place, along with everything else. I'll plug this into the top. And now we have our line, but it's going in the wrong direction. So instead of the end being a positive Z, we can give it a negative Z. But of course we want it to be exactly the same height with our size. So I'll move our curved line over to this side, and we need our size Z to be plugged into the endpoint. To make this a little bit easier, I'll switch over to direction here. That way I can switch this to go in the negative Z direction, and then still adjust the length as a single value. That way I don't need to use a separate XYZ or anything like that. And then I can plug this size Z right into the length. So that's pretty close to what we want, but it's actually going to the very top of our table, and we need to subtract and move it down a little bit. So first let's move it down. We'll start at -3 centimeters from the top there. So now it's stuck right at the bottom of our table, and we could have it intersect a little bit if we wanted to, but let's just stick with -3 centimeters. And then we also need to subtract that from the length. So Shift-A, Utilities and Math. Switch that over to Subtract, and type in 0.03. There we go, now it's always going to be the right size. To give it some thickness, let's use that Curve to Mesh node. Shift-A, Curve and Curve to Mesh. And for this we can just use a circle for the profile curve. So Shift-A, Curve Primitives, and Curve Circle. Plug that into the profile, and let's change the radius to something a lot smaller. Let's say 5 centimeters. Now we might want to change the profile as this goes up and down the curve, but unfortunately we can't change the radius here because it's a circle input, meaning that we can only have one value for everything here. But since it's a curve, we can change the radius along the curve before it gets converted into a mesh. So let's hit Shift-A, go to Curve, and Set Curve Radius. Now we have a diamond socket that we can manipulate. Let's go to Shift-A, Curve, and Spline Parameter. Plug the factor into the radius, but then give this a float curve like before. I'll move this over. Shift-A, Utilities and Float Curve, and flip this around. At the start, which is the very top, we don't want it to be 0. We want that to be 1. And maybe we want the bottom to be shrunk just a little bit. Then we could also give it a little bit more shape to make it more interesting, but since we only have those 2 points, then this isn't going to have any effect. So let's subdivide this. But instead of using a subdivide node, which is going to be exactly the same number of cuts regardless of how big this is, I'm actually going to use a resample curve node, which can give us a dynamic number of points such that they're always an equal distance from each other. I'll hit Shift-A, go to Curve, and resample curve. The count is going to do the exact same thing as a subdivision, but I'll set this to length. Now we'll have a cut every 10 centimeters. Maybe we want a little bit more, so I'll change that to 5 centimeters instead. Lastly, to finish off our single leg, I'll choose Fill Caps on the Curve to Mesh node right at the end, so that it's not empty right at the bottom. Once we have that, we're ready to instance it on the 4 corners of our table. But where exactly are those 4 corners of our table? If we look at our mesh in wireframe mode, we don't really have any points that line up exactly with where we want our legs to be, and we have to instance our legs on some set of points. So let's create a new quad with its corners exactly where we want our legs to be. We already have a quad down here that's pretty close to what we want, so I'll go ahead and start with that. I'll take this one and hit Control-Shift-D to duplicate it while keeping the connection, and then I'll hit Alt-P to clear it from that parent so I can move it outside the frame, and just move this up. Then we can instance the legs on those points. So I'll drag out from the curve, type in instance on points, and plug our leg in as the instance. Now if we look at the final result, we have those instances on the corners, but we don't want that one in the center, so I'll hit Control, right-click and drag, and sever that connection. Now this is kind of close to what we want, but of course we want to inset this a little bit, such that the legs aren't floating out into space. And we probably also want it to be influenced by the roundness control, such that they're a little bit more on the outside when the roundness is low, and moved in more towards the center when the roundness is high. So we can inset this curve a little bit just by subtracting the width and the height. I'll hit Shift-A, go to Utilities and Math, and just switch this over to Subtract. I'll Shift-D and duplicate that down for the height as well, and as long as we plug the same value into both of these nodes, then they'll be inset evenly for all of our corners. Now I want this value to be based off of our roundness, so let's duplicate our input node, Shift-D, grab that up, and plug our roundness right into the value. Now of course that's not going to make sense right away. In the middle it actually looks pretty good, but when we set it to 1, we don't want our legs to be right in the middle, and when it's 0, we don't want them right on the end. So we need to map the range from the roundness to the inset. So let's use a map range node, Shift-A, Utilities, and Map Range, and plug the result into both subtract nodes. We know our minimum roundness is 0 and the maximum roundness is 1, so our from values are fine. We just need to tweak our to values for the output. So when the roundness is 0, let's adjust our to minimum. Let's say we input it maybe by 0.2. That looks about right. And then when our roundness is 1, let's change the to maximum to something like 0.4. And maybe a little bit more. Let's go 0.5. All right. We could potentially run into trouble if we have a table that's too small, and we get our legs that are overlapping, and we could add in checks for that and make sure that they only appear if the table is past a certain size, but I won't worry about that here. Using 4 legs to only using 2 or 1 with several feet. But I'll leave that up to your imagination, and let's go ahead and finish this off. Shift-P to create a frame around them, and parent them. Select the frame, hit F2 to rename it, and I'll just call this legs. Then to make things a little bit easier to read, I'll shift right-click and drag over some of these connections to make a reroute node, and plug those into the front of the frame, just so it's easier to see where they're coming from. And there we have our finished result. We can go into edit mode, adjust the size of our table, and adjust the roundness. There's a lot more that we could do here. We could model some plates and then instance them around our table, and instance all sorts of things like cups and spoons and forks, and we could go really crazy with this, including adding chairs to go around if we wanted to. But I think I'm coming up on time here, so I'll leave the rest of this presentation open for questions, and if there's more time at the end, then we can get into any other details that you might want to add. And that's it. Thanks for watching. As a reminder, I have a full Geometry Nodes course coming pretty soon this fall to cgcookie.com. That'll start out with more simple examples and progress all the way through to more advanced techniques. And also, as I mentioned in the beginning, you can check out orangeturbine.com, where Jason Van Gumster, Dr. John Denning, and I are creating custom tools to help people integrate Blender into their existing production pipelines. So if that's something that interests you, you can also find that YouTube channel. I'll link to both YouTube channels down below in case you want to follow along with both adventures. So again, thanks for watching, and hopefully I'll see you soon.